Hi guys, let's look at the next question. The next question that we do is question number 9. It says OP, OQ and OR are perpendiculars to side BCC and AB. We need to prove AR square plus BP square. Okay, so let's, I can't see any right angle triangles here. So let me just first join O with A, B with O and C with O to create right angle triangles. Correct. So now that we've got right angle triangle, we should be able to apply Pythagoras theorem and see what do we get from here. So point number 1, let's just write what we did. So point number 1, join OA, OB and OC. So left hand side has AR. So AR will be a part of the right triangle OAR. So let's just use Pythagoras theorem there. So in a right triangle OAR, using Pythagoras theorem, I get OA square is equal to OR square plus AR square. So that's point number 3. In the left hand side, they want me to work with AR. So let me keep AR on one side, which gives me AR square is equal to OA square plus minus OR square, So I kept AR on one side and I took OR on the other side, so it became negative. Next, the second element is BP. BP is a part of the triangle BOP. So let's apply Pythagoras theorem in this triangle. So point number 5, in a right triangle OBP, using Pythagoras theorem, what I get is they want BP, so let me keep BP on one side. So BP square is equal to OB square minus OP square. Yes, OB square is equal to BP square plus OP square. So that's correct. So I've done the second element also. Let's look at the third element. The third element is CQ square. So CQ square is a part of which triangle? Let's see. CQ. Also, it's a part of triangle OQC. Yes, it's a part of triangle OQC. So let's look at in right triangle OQC using Pythagoras theorem. And I get, they want CQ. So CQ square would be equal to OC square minus OQ square. Yes, CQ square would be equal to OC square minus OQ square. Perfect. So now my left hand side, I've got all three elements. Let's just write them together. So let's add them together. So add 4, 6 and 8 and we get point number 9, which is equal to left hand side, which is AR square plus BP square plus CQ square, which is equal to OA square minus OR square plus OB square minus OP square plus OC square minus OQ square. So that's the left hand side that we've got. Let's try and work with the right hand side and see if we'll get the same value. So in the right hand side, they need AQ first. So AQ is a part of right triangle OAQ. So using Pythagoras theorem in right triangle OAQ, I get AQ square is equal to OA square minus OQ square. Yes, OA square minus OQ square. Next, so that's the first element from the right hand side. Second element is CP. Let's see which triangle is CP a part of. CP is part of the triangle OPC. So using Pythagoras theorem in a right triangle OPC, we get CP. So CP square would be equal to hypotenuse, in this case OC square minus OP square. So that's the second element we'll get from the right hand side. And the third element is BR. So BR is a part of which triangle? BR is a part of right triangle BRO. Done. So point number 14, using Pythagoras theorem in right triangle BRO, we get BR square is equal to OB square minus OR square. Yes, this is also fine. So now let's add 11, 13 and 15, and we get number 16, which is equal to right hand side, which is equal to OA square minus OQ square plus OC square minus OP square plus OB square minus OR square. Let's see if these are the same elements in the left hand side. So I had OA square minus OR square. So I've got OA square minus OR square. Let's just write them together. So OA square minus OR square. Next was plus OB square. Yes, I've got a plus OB square. Next element is minus OP square. Yes, I've got a minus OP square. Next is plus OC square. I've got plus OC square, and the last is negative OQ square, so negative OQ square. So since LHS is equal to RHS, so hence proved. So these questions are fairly simple as long as you apply Pythagoras theorem again and again in different right angle triangles. Let's look at the next question. The next question that we do is question number 10. So question number 10 says, diagonals of a rhombus ABCD intersect at O. Let's just draw a rough diagram first. So property of a rhombus, diagonals bisect at 90 degree. Yes, diagonals bisect each other at 90 degrees. So that's a rough diagram. Let's just draw the diagonals as well. Done. So this is let's call this point of intersection as O. So A, B, C and D, all sides are equal. It's a rhombus. So let the four sides be equal to X. OD and OB are equal. Let this be Y. And OA and OC are equal. Let this be Z. Done. So we need to prove OA square plus OC square. Let's just write what we have done. So number one, AB is equal to BC is equal to CD is equal to DA is equal to X. Number two, OA is equal to OC is equal to Z. Number three, OB is equal to OD is equal to Y. And number four, angle DOC is equal to angle BOC is equal to angle AOB is equal to angle AOD is equal to 90 degree. We need to write the reason for this. So the reason for this would be, in a rhombus all sides are equal. Next, diagonals bisect each other at 90 degree. So this is the reason why we've taken these assumptions. Now let's work with the left hand side. So left hand side here is OA square. So OA square is equal to Z square plus OC square, which is also equal to Z square. OA square, yes, this is equal to Z square, and OC square is also equal to Z square. So this is equal to 2 times Z square. Let's see if we can get the right hand side also equal to 2 times Z square. Or yeah, let's see. So right hand side will be equal to number 6, 2AD square. So AD is equal to X. So this is 2X square minus BD is equal to 2Y. So that's 2Y whole square upon 2. So this is 2x square minus 4y square upon 2. So 2, 1, 2, 2. So this is equal to 2 times x square minus 2 times y square, which I can write as 2 times x square minus y square, which I can write this as 2 times z square. Reason: since in a right triangle AOD, using Pythagoras theorem, I get x square is equal to y square plus z square, which means z square is equal to x square minus y square. So since LHS is equal to RHS is equal to 2z square, hence proved. Done. We've been able to solve this using the algebra method. Let's see if we can get the same answer without using the algebra method. So I will erase this whatever I have written so that I have some space to solve. Okay, I'll erase this. Okay, reasons here remain the same. I will just remove the variables that we've kept. So I will remove x, y and z. Rest everything remains the same. So we work with point number 5. Left hand side is equal to OA square. So OA square plus OC square. Now OA and OC are equal, so OC square plus OC square, since OA is equal to OC. So left hand side is equal to 2 times OC square. Number 6, let's look at the right hand side. So right hand side is 2 times AD square minus BD square upon 2. So 2 times AD, which is 2 times AD square minus BD, is instead of AD square, I can write this as 2 times OD square plus OA square. Yes, because AD square is equal to OA square plus OD square, and minus BD is equal to 2 times OD whole square upon 2. Is this correct? Yes, this is fine. So this is 2 times OD square plus 2 times OA square minus 4 OD square upon 2. 2, 1, 2, 2. What we have is point number 7. 2 OD square plus 2 OA square minus 2 OD square. Negative 2 OD square and plus 2 OD square gets cancelled, which is equal to 2 OA square. Now which is equal to 2 OC square, since OA is equal to OC, which is, so from 5 and 9, LHS is equal to RHS is equal to 2 times OC square. So hence proved. I have missed out writing a reason here. So this reason is here, 2 AD square. So I'll write the reason here. Since in right triangle AOD, AD square is equal to OA square plus OD square. Done.